So in section 5.1, we were multiplying. So it's just like when you learn multiplication up front. Multiplying is putting it into the parentheses. When we start factoring, which is what we're going to be doing in this section, you're actually taking something out of the parentheses. And so this term should seem very familiar. This is something that you would have learned in middle school math called a greatest common factor. This, however, is the greatest common factor of a polynomial. So when we start talking about greatest common factor of a polynomial, we look at two different things. We look at the coefficients, which are the numbers, and we see, is there a number that goes into all of my coefficients? And then we look at the variables and we say, is there a variable that goes into all of my variables that I could take out or divide out of my polynomial? And once I find that, that is my greatest common factor in my polynomial. And so the first example they give us here, 15x squared plus 45x. So the first thing we are going to look at is we are going to look at our numbers. We're going to say between 15 and 45, what's the biggest number that goes into both of those? Well, that is going to be 15. All right. And then we look at our variables. We have an x squared and an x. So if I have, the first one has two x's, and the second term has 1x, I can only take out the lowest of those because one of them doesn't have as many to give me, right? And so when I look at an x squared and an x, my greatest common factor there is going to be just the x to the first power. Because if I tried to take out two x's, my second term doesn't have two to give me, right? And so with the x's, I'm going to say, well, the largest x is x to the first. That's the most that I can take out here. And then what I'm doing is I'm basically undistributing. So I am actually taking the guy out of the parentheses that I would normally put in when I were distributing. So I am now going to have parentheses here, and I'm going to say, well, what do I have left over? Remember, I am dividing. So if I say 15 divided by 15, that's going to give me a 1. And then I have x squared divided by x. If you have two x's and I took out 1, then I have 1x left, right? Because you really just subtract those exponents. So this is going to give me a 1x here. When I look at the next one, I'm going to say 45 divided by 15. Well, that gives me a 3. And I have 1x and I took out an x. That means there's no more x's left for that particular term. All right. Now remember, when you write this, the 15x, you do not need the 1 coefficient. It is assumed, right? So you can just write an x plus 3. That is the factored form of that binomial. You've looked at your greatest common factor, you've taken it out, and what is left over is what you leave in the parentheses, all right? Now let's look at this next one here. It says, recognize the binomial as a common factor. So this doesn't look like it's finished, right? And so if I look over here, what I am comparing is I'm comparing this to this. And I'm saying, what do they have in common? Well, they actually have an entire binomial in common. You'll notice that the parentheses here is in common, right? They have a 3x minus 7 in common. And so if I were to say my common factor here, my common factor would actually be that entire binomial. That entire binomial would be my common factor. And if I took that out of the first group, all I have left is this 2x. So if I took out that binomial, that first group would have a 2x. And if I took it out of the second group, I would have that plus 5. You still need the plus there, plus 5. And so when it's something like this, you can actually recognize that the entire binomial is a common factor. It is a common factor, all right? And tomorrow we're actually going to do some factoring by grouping using this method as well. All right. So then you now have a different type of factoring. In this type of factoring, you're basically unfoiling. So in the first section of this chapter, we foiled. We had two binomials, we multiplied through, right? And now we're actually going to take a trinomial, so the end result of that multiplication, and we're going to break it back up, all right? The reason we do this is there are times when you're going to have equations and you're going to be able to solve it if you can break it back up, and which is what we're going to do in the third section. And so what we really want to do is look and see what happens when you FOIL. If you start and look and see what happens when you FOIL, then you can start to see how then to figure out what happens when you take it back out. So if I were to give you an example, simple one like this, x plus 2, x plus 3, we could all FOIL this. We would say, well, the first two factors, x and x, that is going to give us our first term. Our last factors, 2 and 3, that will always give us our last term. That middle term is what happens when we do our outer and our inner. So if I do x times 3 and 2 times x, that is going to make up that middle term. And so when I do this, I would have x squared, and I would have 6. That's what happens when I did my outer and my first and my last terms. But then this right here is how I get that middle guy. All right. And so when you start to look at that, then when you start to take it back out, then you can start to see how I'm going to do that. What I'm going to do when I have something like this is I'm going to say, well, the first two terms, that's going to be made up of x and x, because that's how I got my first term. The last one, that 21, that is going to be made up of factors that multiply to give me negative 21. Now, first I have to think about, how do I get a negative when I multiply? Well, the only way to get a negative when you multiply two numbers is for one to be negative and one to be positive, right? So automatically I know one of my factors is going to be negative and one of my factors is going to be positive. They have to multiply to give me negative 21. The other piece of it is those same two factors that multiply to give me negative 21 also have to add up to give me that middle term, just like what happened here. And so then I'm going to say, well, I need two factors of 21 that also add up to give me negative 4, all right? And so then there's a couple ways to do this. 21 is kind of an easy one because there's not a ton of factors for 21, right? I have 1 and 21, and I have 3 and 7. That's about it, right? And so obviously 1 and 21, if one's positive and one negative, it's going to add up to 20, right? Because you're technically subtracting when you have one positive and one negative. Well, that's not what I need. So clearly I'm going to need 3 and 7, right? One's positive, one's negative, which means I'm going to subtract them and get a 4, right? Now I just have to figure out which one's positive and which one's negative. So if I were to unfoil this, my first terms are factors of x. My second term, factors of 21 that are going to subtract, because one's positive and one negative, to give me 4. Well, that's going to be 3 and 7. Specifically, I want a negative 4. So which one is positive and which one is negative? If I want a negative 4 when I add 3 and 7. The 7, because a positive 3 and a negative 7 will give me a negative 4. So let's see how this works. If I multiply my first terms, I would get x squared. If I multiply my last terms, positive 3 and negative 7, I will get negative 21. And when I add my outer and inner terms, negative 7x and positive 3x, I will get negative 4x. That is what I want. What's nice about these is you can always check them. So if I wanted to check them, I would just FOIL. I would say x times x, x times negative 7, positive 3 times x, and positive 3 times negative 7. And you can see that I would get that. And so I know that my answer is correct. X plus 3, x minus 7 is what happens when I unfoil it. All right? Let's look at the next one. I don't have anything in front, so I have an x squared here. I am looking for factors of 24 that multiply to give me positive 24, but that add up to give me negative 11. Now for a positive 24 with multiplication, I could multiply a positive and get a positive 24, or I could multiply a negative and get a positive 24, right? So when I have a positive, I need to figure out, am I going to have two positives or two negatives? And you're going to just look at this middle term and say, clearly I'm going to have two negatives, because the only way to add two numbers of the same sign and get a negative is if they're both negative, right? So now I'm just looking at factors of 24 that add up to give me 11. What are factors of 24 that add to give you 11? 8 and 3, right? So you could go through them. 1 and 24, nope, that's going to give me 25. 2 and 12, nope, that's not going to do it. So you can go through your factors, right? 3 and 8, that's my 11. 4 and 6, no, that's not going to work, right? And so you can just go through your factors and see what works. We know that 3 and 8 will work. So I'm going to say x, and they're both going to be negative. X minus 3, x minus 8. Does it work? X times x will give me x squared. Negative 3 times negative 8 will give me positive 24. And then my outer terms, negative 8x and negative 3x will add up to give me negative 11x. Yes, that is the correct factoring here. All right. Now the last one looks way more difficult, right? We have all this craziness going on. But here's the thing. When you are factoring, your first step is always to look for a common factor. And so the very first thing I'm going to do is look at every single one of these and say, is there something that they all have in common? I'm also going to tell you a trick of the trade is if the first guy is a negative, even if it's a -1, I always take out the negative on the outside. It's easier to factor when your first guy is not a negative, I promise. All right. So I'm going to look at my numbers first. I have -3, positive 15, and negative 36. There is a number that goes into all of those. What is it? 3. And because my first guy is negative, I'm actually going to take out a -3 so that I can get rid of that negative in front. Then I'm going to look at my variables, x cubed, x squared, x. I know I can take out one. How many of them can I take out? I can only take out as many as the least can give me. Right, so I can only take out one of my x's because the last guy only has one to give me. All right, now that I've done that, I am going to divide it out. -3 divided by -3, that's just going to be a 1. I had 3 x's, I took one of them out, so now I have x squared. Positive 15 divided by -3, that gives me a -5. I had 2 x's, I took out 1, so I have 1 left. Negative 36 divided by -3 is positive 12. I had 1 x, I took 1 out, I don't have any x's left. All right. I then want to see, can I factor it anymore? Because there are times when you could potentially unfoil this guy. So if I were going to unfoil him, I would have to find factors of 12 that multiply to give me positive 12 and add to give me -5. 1 and 12 will not do it. That's 13, right? 2 and 6 will not do it. 3 and 4 will not do it. This is actually as much as we can do with the factoring here. All right. If I had something like 7 in the middle, then I could do 3 and 4, right? This doesn't have something that I can go any further with. So sometimes they're going to give you something like this, and the most you can do is take out a common factor. Sometimes they're going to give you a trinomial once you do that, and you can keep going, and you can do what we did over here and unfoil it pretty much. All right. So you're going to have to look and see, can I go any further with what they have given me? And if you can, you're going to. If you can't, you're done. And so this is as much as we can do for this particular factoring. So when you factor by grouping, your first step is to literally put grouping symbols around the first two, put grouping symbols around the last two. If this is a subtraction sign, then you would have to change this. If it's not, leave it alone. All right. Now you are literally just going to take out your common factor of each group, just like we did at the very first example of this section. So we're going to look at this group right here. Between 1 and 4, obviously just a 1. But what about the variables? What variable can I take out here?
X squared.
I can take out an x squared. So if I had 3, I took out 2, I'm going to be left with 1. The 4 doesn't change because we didn't actually divide out a number. And then I had 2 x's, I took 2 out, so I don't have any left in that group. All right? Then I'm going to put my plus sign. Then I'm going to look at the next group. Between the 5 and the 20, I can take out a 5. And so that's what I'm going to do. None of my x's can come out because the 20 does not have an x to give me. So then I'm going to say 5 divided by 5, that's a 1, and I still have an x. Minus 20 divided by 5, that is a 4. And now this looks like the first example that we did. If I look at this, I actually now have a group in common. And so what I'm going to do is I am going to take this group out. That is my common factor now. So I have x minus 4. That is my group that I can take out. And then what do I have left over? Well, here I have an x squared. So put your parentheses, x squared. And then you have to use your operation, plus 5. So we're going to say plus 5 there. All right. So we have x minus 4, x squared plus 5. And that is my factoring. If I were to FOIL those binomials, you would get all the way back to your x cubed minus your 4x squared plus 5x minus 20. So if I were to do first, outer, inner, last here, you would see that I would get that. And you can always check it. So if you have done your factoring, you can always check your factoring. X times x squared, that's x cubed. X times 5, 5x. Negative 4 times x squared. Negative 4, x squared. Negative 4 times positive 5, negative 20. If I put it in standard form, I get x cubed minus 4x squared plus 5x minus 20. That is what I started with. All right. So this is called factor by grouping. Factor by grouping. So right now I want you to do 1 and 3 on that handout. 1 and 3 on the handout that I gave you. All right, I want to talk through these really quickly. So the first one was pretty straightforward. You group the first two, you group the last two. What's in common here is a 4 between the 8 and the 12 and a v squared between these two. So I pulled out a 4v squared as my common factor. 8 divided by 4 is 2. I had 3 v's, I took out 2, I had 1 left over. 12 divided by 4 is 3. I had 2 v's, I took 2 out, the 3 did not have any left. Then I put my plus, and I looked at these two. Between the 14 and the 21, you could take a 7 out. None of the variables could come out. So 14 divided by 7 was 2 with the v left over. 21 divided by 7 was 3. And then, of course, my group in common was the 2v minus 3, which I took out. And what was left over was the 4v squared plus the 7. So this is my factoring. The second one has some commonly confused problems in it, all right? So I wanted y'all to see this one. The first thing I did was group the first two and group the second two. Because this was a minus, I have to change my last guy from whatever he was to the opposite. This was plus, I need to change it to minus, okay? Then I just take my common factor out. Between a 64 and an 8, I have an 8. Between the two variables, I could take 2 of them out. 64 divided by 8 was 8. I had 3. I took out 2. I had 1. 8 divided by 8 is 1. When you are doing this, you have to write the 1 down, okay? If it was in front of a variable, I wouldn't need to, but it's not. I took out both of my variables, so I need to put the 1 there because he is actually minus 1. It's the difference between that and minus 0, okay? So I do have to put the minus 1. Bring down your minus. When I look at the 8x and the 1, I don't have anything in common. When you are factoring by grouping, if you have nothing in common, there is always something. There is always a number that is always in common to every single number out there, and it is the number 1. And so when you are doing factoring by grouping and the group has nothing in common, you take out a 1. All right? And you actually write him. And then you just have the 8x minus the 1, because remember I did change the sign. Now I'm going to look at what I have in common. Well, I have the 8x minus 1 in common. What do I have left over? I have the 8x squared minus that 1. That's why it's important to put it there. Because if you don't, you will have just an 8x squared here. And if you were to foil that or distribute it back, you would not get what you started with. That 1 is very important, okay? So when you are dividing something out and the only thing left over is a 1, you must put him there, okay? You must. It's like when 1 is the only thing left in your numerator. It's important, all right? You have to put it there. All right. So when you are factoring something, you definitely want to have everything in standard form before you start, which means highest exponent to lowest exponent. So I am going to start by rearranging this. I'm going to put the 12x squared first, then the 5x, then the minus 2. All right. Now I am going to look and see between the 12, the 5, and the 2, is there anything in common? And there's actually not. There is no common factor. And so then all of a sudden you start saying, well, my first two terms are not just going to be x and x. My first two terms have to also have a 12. So I have to have a 1x and a 12x, or a 2x and a 6x, or a 3x and a 4x. And there's a whole bunch of combinations you can make to get 12x squared. And then my last two terms, they're definitely going to be 1 and 2. But depending on how I group them will affect my middle term. And so then you start having to look at pairing these things up, which is a method that you can do. You can write all your pairs up and see how they work. The other method, I don't know what they call it. I don't know if it's like called a rainbow method because you go across the top. But what you do is you change this guy into a 4 term. You leave the first and the last thing the same, and you're going to break up that middle guy to be 2 terms that add up to your 5. And the way that you do it is you multiply across. So I'm going to take the 12 and I'm going to multiply across to the 2. All right, so I have 12 times negative 2. 12 times negative 2, which gives me negative 24. All right, so I get negative 24. This is just to help me decide what to do with my 2 middle terms. So now what I want to do is I want to say what 2 numbers multiply to give me negative 24, but add up to give me positive 5. We know if they multiply to give me negative 24, it has to be positive and negative, right? So one has to be positive, one has to be negative. They're going to add up to give me a positive, which means my larger guy is positive and my smaller guy is negative. So now I really just need to know what to subtract to give me 5.
Like 3 and 8.
Right, so I'm going to say 8 and 3 are factors of 24 that will subtract to give me a positive 5. If I do a positive 8 and a negative 3, that will multiply to give me negative 24. That will add to give me positive 5. And so what I'm going to do with that is I'm going to rewrite this trinomial. I am going to leave my 12x squared exactly the same. I am going to leave my minus 2 exactly the same. But for that middle, I am going to break it up to an 8x and a negative 3x. So I'm going to say plus 8x minus 3x. I have not actually changed my trinomial. I've just rewritten it. So I have rewritten it this way to be this. And you can see these are the same thing, right? 8x and negative 3x give me 5x. I didn't actually change anything. I just rewrote it so that I could group it. All right, so now that I have 4 terms, I am going to factor exactly the way I just did on that handout. I am going to group my first 2. I am going to group my last 2. I grouped behind a minus. So that last 2, I need to change the sign. It is currently a negative. I need to change it to a plus. All right? And then I am just going to do my factoring. I'm going to look at the 12 and the 8, and I can say, well, a 4 comes out of 12 and 8. The x squared and the x, I can take an x out. 12 divided by 4 is 3. I had 2 x's. I now have 1. 8 divided by 4 is 2. I took out all the x's I had. Between 3x and 2, it does not have anything in common, so I am going to write my 1. I still have the 3x plus 2 because if you divide anything by 1, it doesn't change it. And then you can see that you have a group in common, 3x plus 2, and what is left over is 4x minus 1, and that is my factoring. That is my factoring there. 3x plus 2, 4x minus 1. All right. So the other method is to list all of your factors. So if I wanted to pair this up, I am going to look at my 3 that is in front of my x squared, and I'm going to look at my negative 14. And I'm literally going to list all the factors. Obviously, 3 only has those. 14, well, that's going to be a positive 1 and a negative 14, or a negative 1 and a positive 14. You have a positive 2 and a negative 7, or a negative 2 and a positive 7, which that's about all you have for 14. If you had more factors, you would have to keep going positive and negative, right? When you do it this way, you have to say, well, what's going to happen when I multiply 1 and 1 and add it to 3 and negative 14? Will that give me 19? Well, no, it won't. So then I'm going to say, well, 1 and negative 1 and 3 and positive 14. Does that work? No, that does not work. And so you actually have to go down this line and you're going to say, well, what about 1 and 2 and 3 and negative 7? Does that give me positive 19? No, that does not. And then you're going to look at the last one, which I didn't mean to do it this way, but 1 and negative 2 and 3 and 20 and 7, 21 and negative 2 actually do give me 19. That's my pairing, all right? So I have to pair the 1 with the negative 2 and the 3 with the positive 7, all right? And so when you write this out, you're going to say, well, I'm going to have a 1x and I'm going to have a 3x up front. That's going to give me my x squared. I just said I need to pair the 1 with the negative 2. What I mean by that is that if my 1 is here, my other outer term has to be negative 2. I'm looking at my outer and my inner terms. So that means that this guy has to be negative 2. The 3x is paired with the positive 7. All right, so pairing can get a little tricky because when you start pairing it, you really have to think about what happens when you multiply outer and inner. And this is my actual factoring of this, but it goes through a process. What I don't like about it is, what if this had been like 12 in front? And I had 1 and 12, and 2 and 6 and 3 and 4 up front. And then I also had to consider 1 and 14. And like when you start getting ones with a lot of factors, then all of a sudden you have a whole bunch of pairing you have to go through, right? And then you have a lot of positives and negative issues that you could run into if you don't pay attention to what you're doing. So you could do this exact one the same way we did it. You could say 3 times 4. And you could say, well, 3 times, or negative 14 rather, 3 times negative 14, that's going to give me a negative 42, right? And then you can say factors of 42 that add up to 19, and you can break it up that way as well. And so you can do the pairing method like they have, or you can do multiply across. But either way, you're going to come up with the same factors. So even if I went through this and did it, I'm going to have the same factors. So I would say, well, in this case, I would say, well, a negative 2 and a positive 21, that's going to give me negative 42. So I could say 3x squared minus 2x plus 21x minus 14. All I did was break up that to these, group it just like we did before. Take an x out, we have 3x minus 2. Take a 7 out, we have 3x minus 2. My group is 3x minus 2. What's left over is x plus 7. Same factoring, different method. All right? So you can list all of your factors and see how you're going to pair them up, but you do have to consider positives and negatives when you do that, or you can do multiply across and break it up into 4 terms to group. I will not make you do it one way or the other. You can do it either method, but you'll always come up with the same factoring if you do them correctly. When we did multiplying, we looked at special cases and what happens with them. And we said, well, if it's the same two, but they are conjugates, remember conjugates are just a plus and a minus, then they end up with this weird perfect square minus perfect square. The first one squared minus the second one squared. If it looks like this, then you end up with the first one squared, the last one squared, and the middle guy is just the 2 multiplied and doubled. And so the reason I taught this to you on the multiplication side is because on the factoring side, it's really nice when you can recognize those. If I look at this first one and I see an x squared and a 25, the first thing I'm going to check is, do I have a perfect square trinomial? How would I know that? Well, I'm going to look at the square root of this. That's x. I'm going to look at the square root of this. That is 5. X times 5 is 5x. If I double it, I get 10x. Yeah, I actually have a perfect square trinomial, which means this is just going to be the x and the 5. If this is a plus, it's going to be a plus, and it's going to be squared. Factors of 25 that add up to 10 are 5 and 5. That means you have the same exact factoring, x plus 5, x plus 5. All right, I'm going to look at my next one. 4y squared, that is a perfect square. It is 2y. 49 squared. 49 is a perfect square because that is 7 squared. Then I'm going to look at the 2. 2y times 7, that is 14y. If I double it, I get 28y. Yeah, this is also a perfect square. This is a minus 28, so this guy is going to be a minus, and I square him. Right? I do want to point out this third term has to always be positive. You cannot have the square root of negative 25 with real numbers, okay? So if that had been a minus 25, automatically I would say this is not a perfect square because negative 25 does not have a perfect square root in real numbers. All right, when we get to complex numbers, that's a different story. But for real numbers, it doesn't have a perfect root. And so this last term has to be positive, but the middle one can be positive or negative. That just tells you what to do here. Let's look at this last one. This last one doesn't look like I have anything actually. But what I'm going to do, the first thing that you do with factoring is look for a common factor. Do 8 and 32 have anything in common? Well, yes, 8. So the first thing I'm going to do is I'm going to take out an 8. 8 divided by 8 is 1, so I have just a squared. 32 divided by 8 is 4. This is not a perfect square trinomial, but it does look like a perfect square minus a perfect square. A squared is a perfect square. 4 is a perfect square, and it is subtracting. So when you have two terms, and they are both perfect squares that's being subtracted, you have a special case, and it's going to be this. It is going to be your square roots. I'm going to leave my 8 out here. The square root of a squared is just a. The square root of 4 is just 2. You're going to have a plus and a minus of the same thing when it looks like that. That is the difference of two squares, and that is a special case. All right, if you were to FOIL it, you would see 2 times negative 2 is negative 4. A times a is a squared, and when you do a negative 2a and a positive 2a, they cancel out, which is why you do not have a middle term there. All right, so if you don't think you have a special case, make sure you've taken out common factors first before you start doing those. They give you the rules of factoring. The first thing you want to look for is, do I have a common factor that I can take out? You want to look for special cases, perfect square subtracted or a perfect square trinomial. And then if you don't have that, if you just have a 1 in front of your x squared, then you only have to worry about the factors of the last term, and you can go straight to your 2 parentheses. All right, factors of the last term that add up to the middle guy. If you have something in front of your x squared, a number, then you're going to have to either pair them up or you have to multiply across and do it by grouping. All right, and so you're going to look for those as you do your factoring.